In our first lesson, we talked about how to write systems of inequalities. So now we're going to talk about how we graph systems of linear inequalities. So let's go back to that first example that we had in the last video about Mr. B selling hamburgers and hot dogs, and he wants to sell at least 10 units. He also charges $5 for a hamburger, $2 for a hot dog, and wants to make at least $30. He only has 5 hamburger buns, so he can sell at most 5 hamburgers. We'll let hamburgers be X and hot dogs be Y. Remember that we have a system of statements, so that means 2 or more rules that we need to have. We determined in our last video that he wants to sell at least 10 units, and from that statement we get X plus Y has to be greater than or equal to 10. From the money standpoint, we need that 5x plus 2y is greater than or equal to 30. And then he only has 5 hamburger buns. So whatever number of hamburgers, or x, he sells has to be less than or equal to 5. So here is our system of inequalities. So here we're going to talk about graphing this system. So we have a coordinate plane, and notice how we are only concerned with the first quadrant. So why are we only concerned with the first quadrant? Because we have hamburgers and we have hot dogs, but we can't have negative hamburgers or negative hot dogs. I also want to draw your attention to the numbers in parentheses after the hamburger and hot dogs. So after hamburgers it says 2. And we're going to use this notation to represent the fact that each of these hash marks are going to be 2. So we're going to start with 0 and then count up by 2. So 0, 2, 4, 6, 8, 10, 12. And then similarly for the hot dogs, we'll start at 0 and then count up by 3 on our y-axis. So we'll have 0, 3, 6, 9, 12, 15, 18, 21. And then we can make an XY table. So x, we know that x has to be less than or equal to 5. So if we choose 5, 0, that would work. Anything would work for that as long as x is 5. So when we graph this, it's going to graph those 2 points. Okay, those would be on that line. And if those are on that line, then our line goes straight up in the air. Notice that we are using a ray here because it has an end point and then it will continue up. Then we can plot some points where x is less than 5, and we see that we eventually get all of these points. So we have this shaded side. So any point in this shaded region is going to satisfy our bottom inequality of x is less than or equal to 5. So let's then look at x plus y is greater than or equal to 10. Again, we can make an xy table. So here we'll choose if x is 0 and y is 0, and we'll see what those points are going to be. So if x is 0 here, then y must be 10, because that's the smallest value we can have. Similarly, if we allow y to be 0, x must be 10. So now on our graph we can plot the points 0, 10 and 10, 0, and then connect those with a segment. We want a segment here because it has 2 endpoints, one on each axis, and we're only being limited to that first quadrant, so we can't have lines that extend on forever. And where would we shade for this side? So we know that other true values are above that line, so the blue region is what makes that specific inequality true. Finally, we can do the same process for our third inequality. So we'll make a table here. Again, we'll try to get x and y to be 0. So here, if I allow x to be 0, my y must be equal to 15 because 2 times 15 is 30. Similarly, if I allow y to be 0, x must be 6 because 5 times 6 is 30. We can then plot the points 0, 15 and 6, 0 and connect them using a segment. Again, it's a segment because we have two endpoints. Other points that make this true are above this line, so we shade everything above that line in green. Now we're looking for the solution. Where are the points that make all three of these true? Notice here we have only pink, and this little triangle it's white, so there nothing is true. In our little section here we have just green. Here we have just, well, this looks like the pink and blue because it's kind of purplish. So if we look at these, we want the region where where all three of them are overlapping, and that is this region at the top that we can shade in blue. So when we graph, this is the only region we really want to shade because it's the only region that makes all three of our inequalities true. So that's where we have all of the possible points are in that section right there. And of course this would continue upward if we continued our graph. So could he sell 5 hamburgers and 4 hot dogs? How can we look at this from a graphing standpoint? Well, if I plot the point 5, 4, is it in that blue region? No, it's not. So he can't sell that many. What about 4 hamburgers and 10 hot dogs? So here we look for the point 410. We see that 410 is in the blue region, so 4 hamburgers and 10 hot dogs is a reasonable amount of food for Mr. B to sell. What about 7 hamburgers and 4 hot dogs? So we'll go to the point 7, 4. We note that this is not in the blue region that is shaded, so this is not a possible combination of food for Mr. B to sell. What about 1 hamburger and 20 hot dogs? Well, if we plot the point 120, we see that this is in fact in the blue region, so this is a possible amount of food for Mr. B to sell. What about 2 hamburgers and 9 hot dogs? So again, we plot the point 29. It is not in the blue region, so this is also not a feasible point or a feasible amount of food for Mr. B to sell. Let's take a look at Farmer Pib. So Farmer Pib here wants to sell some roos and yoys at the market, and he could sell at most 11 units, plan to charge $2 per roo, $5 per yoy, and expected to make at most $40. He had to sell at least 4 yoys. So here we can write our system. We know that we need at most 11 units. So that means we need x plus y is less than or equal to 11. We're going to sell roos for $2 each, so that would be 2x plus 5y, and we need to make at most, and at most again signals us to less than or equal to, so we have 2x plus 5y is less than or equal to 40, and then we need to sell at least, that triggers us to a greater than or equal to 4 yoys. So y is greater than or equal to 4. Here we're going to choose the graph that meets this. So first we need to know, we'll take a look at this first graph. So y is greater than or equal to 4. That's good. We have that. We've shaded above. We want to shade above for that. And this meets it. What about 2x plus 5y? Oh, and I'm sorry, let's look first at x plus y is less than 11. So this corresponds to the line that is now highlighted in green, and do we want to shade this above or below? Well, because we have this less than or equal to, that's going to tell us below. So when we look at this, we want to be shaded below, but we're not shaded there. So we can rule out that as our answer. Let's look at the next one. Y is greater than or equal to 4. Well, that would be this line in green, but that's not even on our graph, so that can't possibly work. Let's take a look then here. We know we need to be above the y is greater than or equal to 4 line, and we are here with this teal section. We're above that horizontal line, so that's good. We're also below the line for y, or x plus y is less than 11. That's also a good thing. So we're above there, we're good. We're below here, also good. Let's check this one. The less than or equal to triggers us to shade below. We are shaded not below, so this cannot be our answer. Therefore, we must have this last option must be our answer.